Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Dear grade 10 students, hello and welcome to this lesson. In this lesson, guys, we're going to understand what is the meaning of fractional indices. We're going to have problems on fractional indices, and we're going also to solve simple exponential equations. But before we start our today's lesson, let's have a very quick revision on the previous lesson. In the previous lesson, guys, we learned how to deal with negative exponents, with negative indices. So I need you to pause this video and try to solve these questions on your own. And the answers will be shown after 5 seconds. And now, guys, let's have our today's lesson, which is fractional indices. Well, so many students might think that the fractional indices is a hard topic, is a complicated concept to be understood. But actually, guys, it's not. Let me explain fractional indices by asking you two questions. The first question is, what do you think? The first question is, what is 16 to the power of 1 over 2? Or 16 to the power of half? And what is 27 to the power of 1 over 3? Okay, guys, even before we know anything about fractional indices and how to deal with the power if we have a fraction, we can think about 16 to be 4 to the power of 2. So actually 16 equals 4 power 2, and don't forget this base, which is 16, is already raised to the power of 1 over 2. And by using the power law of indices, we can simplify this expression. So it will be 4 to the power of 2 multiplied by 1 over 2. And 2 multiplied by 1 over 2 simply equals 1. So here it will be 4 to the power of 1, which means 4. So guys, I can understand that 16 to the power of 1 over 2 equals 4. What if I ask you what is the square root of 16? The square root of 16 simply equals 4. So guys, from here I can deduce that 16 to the power of 1 over 2 simply equals the square root of 16, which is equal to 4. And now let's think of 27 to the power of 1 over 3. Similarly, 27 can be written in the form 3 to the power of 3. So I will rewrite this base to be 3 to the power of 3. And don't forget, 27 actually is raised to the power of 1 over 3. In order to simplify this expression, according to the power law, so we have 3 to the power of 3 multiplied by 1 over 3. And that equals 3. And the same way, if I ask you what is the cubic root of 27, so guys, the cubic root of 27 simply equals 3, and from that I can understand that 27 to the power of 1 over 3 simply equals the cubic root of 27. And now from the two previous examples, we can understand that when you're talking about a fractional index, so actually we're talking about root. So let me give you an example. If I have 9 to the power of 1 over 2, what do you think? Here, guys, we have the base, which is 9, and we have the power, which is a fraction. So whenever you have a fractional power, you need to think about the root. So here inside the root, we will have 9, which is the base. And here we have the square root, but we don't try to write here. So it will be the square root of 9, which is 3. So 9 to the power of 1 over 2 simply equals 3. Let's have one more example. If I ask you what is 36 to the power of 1 over 2, since we have fractional power, think about root, it will be 36. So it will be the square root of 36, which is equal to 6. But what if we have different power rather than 1 over 2? And now, guys, let's have this example. We have 8 to the power of 2 over 3. Previously, we could deal with power of 1 over 2 or 1 over 3. But here we have something different. As I told you, whenever you have a fractional power, think about root. So here the base should be under the radical sign, and we have 2 and we have 3. Actually, 3, the denominator, refers to the degree of the root itself. And 2 in the numerator refers to the power should we raise the base to. And numerator refers to the power that we should raise the base to. So it will be 8 to power 2. So it will be the cubic root of 8 to power 2. And this expression could be written using another form. It could be the cubic root of 8 all to the power 2. Both are fine. And now guys, in order to simplify this, I think the second form helpful. So what is the cubic root of 8? The cubic root of 8 equals 2, and 2 is raised to power 2, so the final answer will be 4. Let's have example number 1, and I would ask you to pause the video and try to solve them. And now let's solve these examples together. And now let's solve them. 25 to the power of 1 over 2. Simply think about a root. 25 will be right here. And we're talking about the square root, so the answer will be 5. B, we have 27 to the power of 1 over 3. Okay, think about cubic root. And here 27, the base will be under the radical sign. So it will be 3. Here guys, we have 32 to the power of 4 over 5. So think about root. As usual, whenever you have a fractional power, think about root. So 4 over 5, 5 refers to the degree of the root itself, and 32 will be the base, and 4 will be the power that the entire expression raised to. So in order to simplify this, 32 can be written, it will be 32 can be written 2 to the power 5 and all to the power 4. And here guys, power 5 cancels fifth root, so the answer will be 2 to the power 4. Let's move to the last one. Okay, since we have a fractional power, think about root. 16 will be the base under the radical sign, and here we have the square root and all to the power 3. And now let's simplify it. It will be like this. The square root of 16 simply equals 4 to the power 3. And you can leave your answer like this, or if you want, you can expand it to be. In this example, guys, we have something different. We have already given the expression. We have already given the expression in this radical form, and you need to rewrite it in index form. So since we have this root, so think about a fractional. So think about a fractional power. Here we have base to be x, and we have fraction, and as I told you, the degree of power is denominator, and the power of the variable will be numerator, so it will be x to the power of 2 over 3. B, we have t to the power of something over something. So it will be, denominator will be 5 and numerator will be 3. So it will be t to the power of 3 over 5. Here guys, we have the same. We have the base to be ab to the power of 1 over 4. And this one will be 2x is a base and all is raised to the power of 2 over 3. In example number 3, guys, we're going to solve some exponential equations. So let's start with A. Here, guys, we're given 2 to the power of x equals 8. And we need to find out the value of x. When you're dealing with exponential equation, you have one target. Your target is to make equivalent bases. So here we have the base to be 2. Okay, guys, so I know that 8 equals 2 to the power of 3. And here we have 2 to the power x. And since we have base equal base, so power equals power, so we have x to be 3. This is the answer. Here, guys, we have 4 to the power of x equals 1. And we could think of this. 4 to power x simply equals 4 to power 0, since any number to power 0 equals 1. So I can rewrite 1 as 4 to the power of 0, since we have base equal base, so power equals the power, so x equals 0. And now guys, let's deal with C. We're given that 81 to the power of x equals 3. And now my target is to make equivalent bases. I need to make the two bases equal to each other. So think about 81. 81 can be written in the form 3 to the power of 4. But don't forget that the entire expression, the entire 81 is raised to the power of x. That will equal 3. And now according to the power law, 3 could be written like 4 times x, which is 4x, equals 3. Since we have base is equal to the base, so power equals the power. So we have 4x equals 1, and from that I can say that by dividing by 4, x will be 1 over 4, and this is the value of x. Okay, the same way guys, I need you to think about this one. 16 to the power of x equals 2. So my target right now is to rewrite 16 to be 2 to the power of an integer. 16 simply equals 2 to the power 4. And don't forget, 16 actually is raised to the power of x. That equals 2. And now, 2 to the power of 4 times x, which is 4x, equals 2. And the same way, since you have base equals the base, so the powers are equal. So 4x equals 1, and from that, by dividing by 4, x equals 1 over 4. That's all for today's lesson, guys. Thank you so much for listening. See you inshallah later on. Bye bye and have a nice day.